In today's note, we're going to be looking at charging by friction. So charging by friction is seen when static charges build up on different materials that are rubbed together. So we talked about static electricity in our last note and how it's the charges that remain on a surface, and how charging by friction is when something's rubbed together. So when we rub two objects together, usually one material has a stronger attraction for electrons, and that will pull electrons from the other material. The object that pulls electrons will become negative, and the object that gives up electrons will become positive. This works because when you have more electrons than protons, you have a negative object or a negative charge, and when you have more protons than electrons, you're going to have a positive charge. So if we have two neutral objects, they have equal number or the same number of protons or positive charges and negative charges, and if we rub these two objects together, what will happen is that one will become positive and one will become negative. This is because the one we see here, the one on the right is negative because it has a stronger affinity for electrons, so it's going to pull the electrons from the other object on the left, thus causing the one on the right to have more electrons. That makes it negative. The one on the left, again, because it lost electrons, is going to become positive. The electrostatic series is a list of the ability of substances to hold onto their electrons. So basically, it's a list of how well a substance can hold on to electrons. And this is what can be used to determine whether or which substances will get a negative charge and which substances will get a positive charge when you rub them together. Remembering that if electrons are lost, you're going to have a positive charge because you're getting rid of negatives. And if electrons are gained, you're going to have a negative charge because you're gaining negatives. So this is our electrostatic series. We can see on the left, we can see all the different materials. It's acetate, glass, wool, fur, calcium, silk, aluminum, cotton, wax, ebonite, plastic, carbon and copper, rubber, paper, sulfur, gold, and so on. So those are different materials, some that we may come into contact in the course. But the way the list works is at the top, those objects or materials are weak. So they're weak at holding electrons. And as you move down towards the bottom, there's an increasing tendency to gain electrons. And at the very bottom, those objects or materials are very strong at holding on to electrons. So the items at the top would end up being positive compared to the items on the bottom, because the items on the top don't want to hold or struggle at holding on to those negative charges or electrons. They're going to give them up or give them away to the stronger materials, therefore leaving them positive. The objects closer to the bottom, or as you move down, they're going to gain these electrons because they're stronger. They have a stronger affinity for holding on to the electrons. So they're going to have more negative charges, which makes them negative. So we can just see kind of an example with rubber and fur. If we're rubbing those two objects together, the rubber is lower on the chart, so it has a higher affinity or a higher tendency to gain electrons or hold on to them. So it's going to pull the electrons away from the fur. So again, there's an increasing ability to hold electrons. When rubbed together, the substance that is closer to the bottom will become negative, and the one closer to the top will become positive. So again, based on this image, the fur was closer to the top, so it became positive. Rubber was closer to the bottom, it became negative because it pulled the electrons from the fur onto the rubber. So just looking at some examples using our electrostatic series. Rubbing paper with fur, which object would become positive and which one would be negative? Well, looking at them, paper is further down the chart than fur. So based on that, paper has a stronger tendency or a higher tendency to hold on to electrons. So that means that paper would end up being negative and fur would end up being positive. Rubbing a plastic bag with glass. So again, we're going to find those two objects on our chart. We can see glass is near the top, is the second one, And then plastic is towards the bottom, right above carbon, the polyethylene. Again, because plastic is further down, it means it has a higher tendency to gain electrons or hold on to them. So it's going to pull electrons from the glass, which means that the plastic bag should end up with a negative charge and the glass should end up with a positive charge. So again, plastic will become negative, glass will become positive. Rubbing a sheep with a tire. So sheep covered in wool and tire is made up of rubber. So looking again at our table, wool is near the top and rubber is near the bottom. That means in terms of the wool, it doesn't have a high tendency to gain electrons or hold on to them. So it's going to be more likely to give them away or have them pulled from it. When you lose electrons, you're going to end up being positive. So that means rubber would end up being negative. So the sheep or the wool will become positive and the tire or rubber will become negative. And lastly, combing Chester's fur with a plastic comb. So fur or cat's fur is again near the top. Plastic is down near the bottom. Again, the same spot for the plastic bag, the polyethylene. So again, because cat fur is higher on the chart than polyethylene or plastic, that means plastic is going to pull electrons from the fur. Because it's going to pull the electrons, that means more electrons will be on that plastic comb, which will make it negative, and then the Chester's fur would be positive. Right? So again, the plastic will be negative and the fur will become positive. So again, the idea from this is to understand how we charge by friction, which would be two objects rubbing together, and how that works in terms of one object pulling electrons from the other to create a negatively charged object, and one object losing electrons that were pulled away, making it positive. And then we use the electrostatic series to help us figure out which object will gain electrons and which object would lose electrons.